Surface temperature -63. Your job, terraform it. Make it livable.
What do I have to work with?
A terminal, basic equipment, and whatever you can build. Everything on this rock runs on code. You will set up power, repair broken sensors, build infrastructure. Every machine you deploy is yours to program.
Writing code to fix a planet. My resume's gonna look interesting.
Just make sure the planet looks good first. There are resources on the surface worth money. Scan, harvest, ship it back. Earth pays on delivery. And Commander, the better this planet shapes up, the bigger your budget gets.
The brochure made this sound like a piece of cake.
We'll see about that, Commander. Good luck out there.
Okay, so first of all, I want everyone to keep this to themselves and please don't call in Lollipop, because I'm a very basic level coder. This is nowhere, anywhere gonna be good code. Like, anywhere. So, okay, switch to the code tab, press type boot and click play to run. Okay, your terminal is connected to the remote station on an uninhabited planet. Wow, nothing is running yet. To start, boot the system. This runs diagnostics and brings the station online. This is your first command. Type it in the code tab, then click play to run. Hey, if it runs, it runs. Yeah. Console. Hello? Code. And then run. Signal required, establishing link, connecting stable, etc, etc, etc. Okay, cool. The system is booting, but the power grid is offline. Without power, nothing else can come online. Activate the power system to start generating energy. Activate _power. Power is online, sensors array can now be activated to start reading the planet's environment. Once online, sensors will report temperature, pressure and oxygen levels, but 2 of them need repair before they can work. Okay, activate sensors. Okay, we have a temperature. Uplink. Earth needs to verify your instruments are working. Connect to Earth, read temperature and transmit it back. Get the thermometer and transmitter components. Read temperature. Connect to Earth and transmit the reading. Every piece of equipment has a name. Click info on any sensor and sensor card to use it. Use get component with the name to access it in code. Earth expects this key with the temperature value, current temperature. See also thermometer and transmitter. Okay. Can I get a secondary tab? No. Okay. Get components a thermometer. Is it with the thing? No, it's without. Can you dock in the window? No. I can make it out to dock, but not really dock. Get the thermometer transmitter. Every piece of equipment has a name. Click info on any sensor card to see it. Use get component with that name to access it in code. Button at the bottom it says dock next. Oh. Oh, that might actually... Okay, let's dock this again and then see that we have all of this. Okay, cool. If I do this... Okay, but what? Perhaps we need to turn the power on first. Okay. What value do we have? Like we need a value, right? Okay, read. Get value? No. Documentation. Result self-scan E14. Scanner scripts. Okay. First steps. First contact. The boot power sensors uplink tutorial chain. You have 1,000 credits in the shop and biology lab are unlocked. This page is the same handoff guide that appears once after the tutorial completes. Reopen it here anytime if you want to refresh it. Pressure sensor and oxygen sensors are already deployed. Click repair on either card to bring it online with a calibration script. Open the shop in the left sidebar and buy a solar generator and battery. Open inventory, deploy variables. Variables store values that you can use later. Exits 10, name oxygen, activate as true. You can use variables in expressions. Yeah, okay. So we require a new thing called current temperature. Do we have a list of expressions? I have a list of functions, but core systems, transmitter. Oh boy, okay. Sensors, thermometer. Get component thermometer. And then properties.name. Get value. Oh. So this would mean value equals no. Current temperature equals oh. Your temperature. And then value equals temperature dot get. Yeah. Minus 63. Cool. Now we need an uplink. Transmitter. Communication array for sending data to other planets. Most used case, submitting contracts, answers back to Earth. Connect picks a target planet. Transmit key value. Sends a key value payload. Connection lives only with the current script run. Every script that transmit must connect first. Always expose list planet. Connect. Get info transmit. Get components transmitter. So then connect to planet. No. So transmit. Key and value. Contract ID. Contract ID is Info transmit. Send the key value payload to the connected planet. Transmitted, transmit, contract ID, answer. For contracts, the key is the contract ID and the value is the computer answer. Game validates on arrival and either pays the credits plus prints success or prints an incorrect hint. Return none in both cases. Success is observed via credits changing, not return value. Requires connect first. Prints and errors are no ops otherwise. Arrives the same tick as it was sent. So contract idea. Contract is not defined. Yeah, fair enough. Yeah, connected to Earth, so that works. So I don't even need this. If I do this should work. Yeah, so minus 63 is our current temperature, and connected to Earth is our current connection to Earth. Cool. Now, return by self.contract. Yeah. Self is not defined. Get component contract. This contract a component. I need a contract ID, don't I? Expected string for key. Okay. Oh, okay. Is that it? If I can write, maybe. There we go. Wow. Achieved first contact. Transmit your first sensor reading to Earth. Open docs to see more. They've received your transmission. You earned 1,000 credits, and the shop and biology lab are now open. Pressure sensor and oxygen sensor are already deployed. Click repair on either card to bring it online with a calibration script. Open the shop in the left sidebar and buy a solar generator and a battery. Open inventory and deploy both. Click manage on the solar generator card to script its tracker. Okay. Okay. Got it. Now, I want to repair this. Sensor is offline. Its hardware works, but the readings need software processing. Sensor output raw values like 0.047, but the system expects numbers like 0.7. Read the current number from the sensor, convert it to the correct format, and calibrate the sensors with the result. Read the actual value from the sensor, don't hardcode numbers. The reading changes. Okay. So we start with get components, and then oxygen sensor. And then oxygen equals oxygen. No. O2 sensor equals that. O sensor dot get value. And then oxygen corrected equals oxygen times 100. And then so it reads part per trillion, needs something smaller, I guess. Yeah, I guess so. Hey, look at that. Nice. One, two, yeah, that's correct. I believe so. Unless I'm completely mistaken. Unless I'm completely mistaken. Okay, that seems like I'm not completely mistaken. Cool. Pressure. Sensor is offline. Okay. Corrupted readings are odd numbers. Valid readings are even. Okay, examples 17 odd, so add 1. Evens already valid. Console confirms it. Yeah, okay, fair enough. Yes, okay. Read the current value from the sensor. If it's odd, add 1 to correct it. If it's even, it's already valid. Stabilize the sensor with the results. Okay. So, get components, pressure sensor, B sensor equals that. Now, value is pressure raw equals B sensor dot get value. Yeah, lowercase. Okay. Now, I do know about... If... pressure raw modulo 2 equals 0. Pressure equals pressure raw. Else pressure equals pressure raw plus 1. And then P sensor dot count. How do we do that before? Oh yeah, of course, it's double equals. No. If pressure raw. Got no line. Okay. I need documentation. If else. If temp higher than 0. Oh, right. If else. Make decisions based on conditions. If temperature higher than 0, above freezing, else lower than 0. Okay. So there is something in this. Okay. What are... No. I believe there is something like a modulo. Max round. Huh. Yeah, this is what I'm trying to get, right? So, okay. I'm gonna take this up. Modulo, in computing and mathematics, a modulo operator returns the remainder of the signed remainder of a division. After one number is divided by another, the latter being called the modulus of the operation. So in this case, I specifically want to see if a number, pressure raw, divided by 2 equals 0. If that is 0, it should go on. And I believe a modulo is generally designed by a percentage. So line force after if condition got might need a for loop. No. So apparently it can be, because this is a thing that's in the game. Like, this is literally written in the game. Can we get a readout of the current pressure number to see what it's pulling? Yeah? 31. Is it this? Yes, it's literally that. Okay, cool. So these with the hashtag in front of, they should not change the value that we have. Okay. Okay. $31 divided by 2 doesn't equal 0. How does it get us to even or odd numbers? Yeah, so if pressure raw, which is currently what we are reading, modulo 2, which is pretty much this, equals 0, then we have an even number. Then we can have this. Otherwise, we have that. So if I do this instead, yeah, that doesn't work. 6. Expected indent at start of block. Okay. No clue why this works and the opposite didn't. Okay. Pressure sensor now online. Okay, cool. Let's okay, we have all this. Let's go back to info. This is what we have. We need to get a solar generator and a small battery. And then we needed to deploy them. Oh. Pressure sensor is pressure sensor and oxygen sensor are already deployed. shop, solar generator, battery, open inventory, deploy both. Click manage on the solar generator card to script its tracker. Okay, so power. Manage this. Clock get elevation. Okay, convert sunlight into power. The panel produces more power when it's pointed directly at the sun. The sun rises, moves overhead, and sets. Its elevation ranges from 0 on the horizon to 90 straight overhead. The panel has its tilt to adjust from 0 flat to 90 straight up. The panel works best if it's perpendicular to the sun. Sun's elevation and your panel's tilt should add up to 90. For example, sun at 60%, tilt at 30%. Sun moves constantly, so your script needs to keep adjusting. Your generator is already loaded up self. Use the clock component to read the sun's elevation, then call self.setTilt degrees to aim the panel. Clock.getElevation reads how high the sun is, always between 0 and 90. Wrap your logic in while true, so it runs forever. Script that runs one tilts the panel a single time and ends. Okay, so we should now have solar panel equals get components solar 1. Then self.setTilt degrees. Clock.getElevation. No, clock is not defined. Clock. Get component clock. Okay, yeah, fair enough. So now it's 90, and if we check it now, it should be 90 twice. Okay. So, while true. Okay. Self.setTilt equals 90 minus sun degrees. Print. No, I do not want to print it constantly. After while condition got new line. While loop. Oh, just no. While. While true. So it runs forever. Power is flowing, but it says that here. Oh. Oh, it's working, okay. Gosh darn it, I'm a dumbass sometimes. Sometimes I'm just completely forgetful. That's the one. So we should get full in 16 hours. Cool. Cool. This is the comfortable coding mode editor. Console, docks and other windows, all tabs. Click undock highlight to return to the floating. Yeah, fair enough. That's that. Now we should be fine on this. If we go back to the documentation, which is right here, we have first steps. Yes, you can do this. You can do this in any order. This sequence just gets easier. Scripts written first while you also build out your power. 3 paths increasing in difficulty. Biology lab. Recommended start. Recover frozen biological traces near the base. Analyze them into samples. Then feed the bioexchange for steady credits. Short scripts. Clear goals and progress you can see without leaving the base. Cool. Let's get the biology lab. Shop. Biology. No. Biology lab. Okay. Awaiting specimen. So biocollector. Step 1 for the biology loop. The biocollector does the same job as the manual collect button. Pick up a fragment dot, send it to the collector out, and bring one specimen back to cargo. The important idea is small. Scan gives you choices. Collect uses one choice. Every script is attached to one machine. If that script self means this machine, since this is the biocollector's script, self-scan means ask this biocollector to scan, and self-collect means tell this biocollector to collect. Okay. All the machines work the same in their own scripts. Inside the biolab script, self is the biolab. Inside the bioexchange script, self is the bioexchange. Some methods are hardware actions like pressing that machine's own button. Collect, analyze, extract, sell, move, drill, charge, and similar commands. For machines with their own script slots, those actions usually belong to in that machine's own script through self. Although scripts may read, state, or pass a component's reference around, but they should not try to dive another machine's hardware directly. Docs, those methods are marked self only. From manual to code. When you click on a dot on the biology map, you are choosing coordinates. In code self.scan gives you those coordinates as a list. A list is a ordered row of values you can count in with len. You can pick one entry by index. Indexes start at 0, so sites 0 means the first site. Sites equals self-scan, print len sites. Here, sites is a variable. The variable is just a name you give to a value so you can use it again on the next line. Each site has chords and distance For first script, do not worry about the perfect route. Pick one nearby site and prove that collection works. Site equals self. If len sites target case and collect. If the if line is a safety check, only pick site 0 if the list actually has something in it. Yeah, fair enough. So we can literally just go this. Right? Yeah. That literally just worked. Cool. The collector has one cargo slot. If self-cargo already holds a specimen, the next step belongs to the biolab, so the collector should wait. Useful automation shape is, if cargo full, wait, otherwise scan, pick one site, collect it, repeat. Okay, fair enough. So, if self.cargo more than 0, else if self-cargo equals more than 0. So if we have cargo, that's actually not correct. We want that to happen when this happens. Can I return it to the data collector? Target. We don't even need that. Step 2 and 3 of the biology loop. The biolab does what you did manually: analyze, reagent, load, and extract. This machine teaches a useful programming pattern. Read the current state, then choose the next save action. The script runs on the biolab, so self is the biolab. Put the specimen back in the biocollector's cargo. To talk to that other machine, ask the machine for its idea. Okay, collector equals get component biocollector 1. That's this one. Get component gives you your script a reference to other components. You can pass that reference into lab methods like self take from collector. Think of it as saying biolab, take the specimen from that biocollector. Notice what the lab is not doing. It's not calling collector collect. Collection is the collector's hardware job, so the collector script does it with self.collect. Lab only uses the collector reference as a source for its own hardware action, self take from. In docs, these local hardware methods are called self only. Okay. Move a specimen from the collector lab, analyze it, read the recipe, load the matching reagents, and extract the sample. In code, the lab input tells you where you are in the flow. Okay, so let's first of all, collector equals get components biocollector 1. And then they asked us to self take from. Self take from collector. And then I shall print done. There we go. Yeah, okay, so that works. Now, self-analyze. Okay. Fruiting body. Analyze your first specimen in the biolab. Okay. If the input exists but it's still only collected, analyze it. Self.input and self.import.stage equals collected. Info self.analyze print info.required recipe. Okay. Info is the return value from analyze. This is pretty much what we're working on right now. Who's, After analysis, recipe is available on the specimen. It's a dict. Reagent ID quantity. A dict stores values by name, so recipe reagent means look up the quantity for this reagent ID. Recipe self-input recipe. Okay. For reagent in recipe keys, need recipe reagent. Load self-loaded reagents, get reagents 0. Okay. Okay, we need alkaline buffer and cryo solvent. Okay. For loop runs once each reagent key in recipe. Get reagents 0 means read the load amount or use 0 if that reagent is not loaded yet. Once the loaded reagent matches recipe exactly, self-extract turns the specimen into a sample item in inventory. Okay. So he is awaiting specimen. Oh, power system needs to be activated again. No. Hmm. We have a contract for lab work. We have this one. Most biolab needs to identify alien gene sequences. We resolved 1,000 samples from organisms on the planet's surface. Earth sent us 50 known Earth genome sequences as reference. Extract all samples that are not found in the Earth reference set. These are the alien sequences. Transmit them as a list. This feels like not necessarily what we are doing at this point in time. Like, okay. Group of frozen biological traces in their base, analyze them into samples, then feed the bio-exchange for steady credits. Short scripts, clear goals, and progress you can see without leaving the base. Orders, self-orders, print-len orders. Okay, it literally just says 10. Okay. Frost tissue sample by unfrozen requires MA cranial papilla 3. Reward 700 standards available. Delivered MA cranial papilla 0% 0. Okay. Okay. Self-set order, that order. Self-deliver to hand over samples one at a time. Is that a thing? No, that's not a thing, huh? So we have given 3 of them. No, we need 3 of them. It does not deliver though. Oh wait, do I need to like literally... Self-analyze, self-load, self-extract might be the one. Self-load reagent ID quantity. That we should be able to see from self-analyze, don't we? Required recipe. Hmm. Error line 8. Load the recipe reagents first. Buy anything missing from reagent stock. That's this, right? Yeah. I actually kind of would want 2 of these. Can I get a second one of these? No. Gosh darn it, okay. Ah, I can? Yes. Cool. So get component biocollector 1 is the one that we need. That's going to be collector, and that's going to be fine. If not self-input, self-take from collector. We have currently taken that here, but if... Not self-input means the lab has no specimen right now. This is a common script pattern. Check what the machine currently has before telling what to do. If the input exists, that but is still only collected, analyze it. So that's literally that part of the code. once again says none. Oh. If there's no input in self, take from the collector. Else, print the stage of where it is. And now it jumps to line 8. Attribute error cannot access recipe on none. Yeah, fair enough. Info is returned from analyze. None. Okay. So we have nothing. So it might mean we have to go back to this one. So while true, this is just to keep it going. If self cargo equals 0, if there's no cargo in self, sites self scan. So I'm gonna scan about what's going on. Print len sites. So this is pretty much what this prints. This doesn't do anything. Okay. $16 sites. Okay. Then sites equals self scan. We have had that. Yes. And then if len sites greater than 0, this is just to make sure that it's got something. Target equals sites and then square square brackets. And then self.collect targets.quartz. Collector has one cargo slot if self.cargo already holds a specimen. The next step belongs to the bio lab, so the collector should wait. Okay, if cargo is full, wait, otherwise scan. Self.cargo not equals 0. Okay, this one is collecting. If I do this while true, this one keeps on running now. So this I need to stop. So collector equals get component BioCollector1. If not self input, self take from collector. So if there's nothing in my self, take from the collector, and then self input. Print what I took. Info, pop out this. Okay. Specimen coords 50-50, distance 71, stage collected. Fragment ID none, rarity none, recipe none. Okay. After moving it from the collector, I need to analyze it. It's then self.analyze. Then info equals self dot no. And then for agents in recipe dot keys need equals recipe reagent loaded equals self dot loads and reagents dot get reagents. Okay. Oh. Did I lose all my power? Yes. I might have to take a second solar panel. Yep, now it's working. Cool. That was dumb. Yep, reach 100% solar efficiency. Cool. Yep. Okay. Would like to see it go down as well. It's not. Okay. Okay. What do I do with those? Oh, these are different ones. Cool. Ah, okay, I have to find one with the thing in my inventory. So these two now work. I guess we need to eventually automate to buy enough reagents, yeah. I just wouldn't know how. I'm gonna stop that for a second because it's driving me crazy. Yeah, okay. Let's commentate what each block of code is intended to do. What do you think I am, a coder? Orders. Okay. Besides, because none of us are coders, we need to be dungeon and commentating, otherwise we'll lose track of what we're doing. Yeah, fair enough. So we currently have 10 orders. To be honest, that would be quite a thing, wouldn't it? Oh, is it already 3 hours? Yes, it has been 3 hours. Wow. Okay. That went by quicker than I expected. Huh. Time flies when coding. Yeah, apparently. Do we want to come back to this? Like, this demo feels way bigger than it is right now, or do we just want to go and be like, yeah, you know what, fuck it, we're done, we did this? I actually might want to put this game on my wish list. Huh. It will release in approximately 7 days. Yeah, I think I'm fine with this. I'm gonna put it on my wish list at the very least. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 more demos to go through on Steam, let alone demos that are on my Switch. So we might. This was fun. Okay. I'm gonna send you all over to a friend of mine who's currently playing Final Fantasy XIV Online. No one saw that one coming. Hope y'all had a good day. Hope y'all had a good time. I'm not sure if I can play games tomorrow for stream. I will be at my friend's. We will be back on Wednesday with the game that we're playing, Pokemon Legends ZA. We'll be back. That being said, hope y'all had a good day, hope y'all had a good time. I'll see y'all again next time for more whatever this is. Have a good one. See you later. Goodbye.